Good afternoon, this is Schweitzer, and this is a little video on collisions with multiple dimensions. So essentially we have two things colliding, and rather than them colliding on the same plane, they would be either both on the X plane or both on the Y plane. We're looking for things that might be going at multiple angles. So one item is going, let's say, it says here we have a car, and it's traveling straight to the east at 15 meters per second. And then I have another car that's angling at a different angle, like that. And the angle on this guy is, from the north, is 15 degrees. Okay, and it's only traveling 5 meters per second. Alright, so we want to know these two cars. This is also a car. It has a mass of, alright, well, the first one is 1,500 kilograms. And let's say the second car, I don't give a mass, let's say this guy is 2,500 kilograms. Alright, so this guy is 2,500 kilograms. Alright, and this thing forms a conglomerate mass that will then simply travel at some angle like that. Alright, so first things first, I want to create, well, let's do the momentum of each car first. This guy has momentum equals mass times velocity. Now I'm going to do momentum first, but you don't have to. You can leave it in velocity if you want, and then simply multiply it times mass afterwards. But momentum being a vector, the velocity vector, momentum a vector, we can then do this before or after. 15 times 1,500 equals 22,500. For this, I am going to create an IJK table. There's no K, so I'm going to leave it off. This is car 1, car 2, car 1, car 2. And it's only moving in the X plane. So this guy is 22,500. Nothing in the Y plane. And then we have this guy. Now this is where we get a little bit different scenario here. Now I have this guy traveling at, well, it's going to be 2,500 times 5. Pretty simple math there. 12,500. Okay, and this would be units of kilograms. Well, it's unit of momentum, which doesn't have a special name. It's just kilograms meters per second. So again, that's not something that's real keen in this particular spot. So now this guy goes here, and let's draw my line right here. Come on, there we go. And then here we go. So this makes two vectors, and I want to figure out essentially my I component and my I component and my J component. So this angle is 15 degrees. So we always put together these formulas that we can just stick numbers into. For example, the I component is equal to the magnitude of the hypotenuse times the cosine of the angle. And then the J component is equal to the magnitude of the component times the sine of the angle. And this will work every time. If you were to run the angle from the zero component, so at this point, this is 90 plus the original 15 would make it the total angle 105 degrees. So this will not only give you the correct sign, but it also will give you the correct side. Of course, I would probably encourage you to, anytime you're doing some trigonometry, if possible, if the problem is too complicated, to always keep an idea of what you're actually solving for trigonometrically. This guy is 15. This triangle is not too much better than the last one, but if I were to do just this way and say, okay, cosine of 15 and times the, in this case, actually I can't do that one yet. In this case, it's 12,500. That's what I'm looking for. For some reason there it goes. Okay, good enough. Would be 12,500. Okay, what does this give me? Now, again, if you're not watching closely, you're anticipating this to give me my I component. But if you look at it, 12,500 times the cosine of 15. It gives you 1,274. 1,274. And if you're paying attention, you realize that, well, if this guy here is only 12,500, how can the short side be 12,074? And the answer is it can't. So in this point, if you use the 109, you get a slightly different version. So in this case, what we're actually solving for here is the cosine, which is the adjacent component, which happens to be j, the adjacent over the hypotenuse, which is what this is working with. This is actually the j component. So be wary that if you use your angle and you're trying to use these shortcut dealies here, that it's not always going to work. Okay, be careful. The main thing is you must use not the 15, but the 105. This would, of course, be my y component. I'm just going to write that down here. So this is my 1250 times the sine of 105 will give me 12074, and it is positive because it's going up. And then this other guy would be the cosine of 105. Equals a negative 3,235. So this is a negative 3235, and this is a positive 12079. All right, so we're just moving along here. We got a few more pieces of information. I have my components. I have them in an IJ table. I'm going to come up with my overall IJ components. This is a positive 19264, 12079. And I'm now just simply going to be rebuilding my new vector. I have in the I component, which is the x, I'm going to go this way, which would be 19264, and then my j component will go up. All right, and this guy is going to be 12079. I will therefore find my hypotenuse. So we're going to use Pythagorean theorem for this guy. 12079 squared plus 19264 squared equals my hypotenuse component squared. And I'll just square root this whole thing in order to eliminate that. Alright, and my answer if no mistake was made, 22,738 is my momentum of the whole of my hypotenuse. Okay, now let's take a moment and let's figure out the actual velocity. Now momentum is mass times velocity. Momentum being 22,738 equals my whole mass. The whole mass of this thing is going to be, the original one was 1,500, 2,500, I guess that would be 4,000. Okay, so put the 4,000 in here, and then we have the velocity. So momentum divided by 4,000, and we get about v equals 5.6 meters per second. And my angle, that's one thing I want. My angle is going to be this angle. Of course, you should note that my angle will be east of north. Okay, I have two positive components. At this point, having all three sides of the triangle, I can simply solve. Let's do this guy right here. I'll put it in this little side here. So the inverse tangent, or the tangent of the angle, is equal to opposite over hypotenuse. It's going to be 12,079 over 19,264. And I'm getting 32 degrees. 32 degrees east of north. Minus any calculator errors. There we go. Our overall goal is to see we've got two cars and they're colliding, form a new mass. I got 5 miles per hour, I got 15 miles per hour, 1,500 pounds, 2,500 pounds, or should say kilograms. It will then have a velocity of 5.6 meters per second, and the angle will be 32 degrees east of north. And that's that basic type of problem. Thank you.